Example. So we let T be the linear map defined by T. So it is from R2. Therefore, we have T x1, x2. This is equal to R3, x2, negative 5, x1, plus 13, x2, negative 7, x1, plus 16, x2. Then what is the key issue here? We want to find the matrix. We want to find the matrix representation of T. Matrix representation of T with respect to bases with respect to bases B. B is equal to U1, U2 for R2 and B prime with V1, V2, V3 for R3 for R3, sorry, R3, where U1 is equal to V1, U2 is equal to 5, 2, V1 is 1, 0, negative 1, V2 is 1, 2, 2, V3 0, 1. Yeah. So we are given a transformation from R2 to R3, and you want to obtain the matrix representation of that transformation. But the representation should be with respect to the bases B and the B prime. B has U1 and U2. U1 and U2 have been given. B prime has B1 and B2. They have been given. So how does that matrix look like? Now look at what I've been writing there. I cannot refer to it because I've been running off. From that block of T, this is what we are supposed to determine. Now you see that here I have B, which is made up of U1 and U2. B, from that definition of the matrix T, which you have there, this is what we are supposed to obtain from that definition of matrix T. We are supposed to determine, so we find the following. So this is now made with the TU1, from the definition, not the second definition. The second definition was for V equals W, but I am referring to the other first one. First one. Because that second one is for V equals W when you are having from the same thing to the same thing, but these are different things. Yeah, from R2 to R3. So this is what we are looking for. So meaning that to obtain this, we have to first look for that thing in yellow. We have to find that. We also have to find those columns. We have to obtain those column vectors. Now, if we have those column vectors, we can substitute them. So you see, we want TU1. TU1. So I know T, I know how T is defined. I also know how U1 looks like. Therefore, TU1 is equal to T. What is U1? U1 is 3, 1. Now you substitute in your T. Look at our T. Our T starts with X2. Our T starts with X2, according to the way how it is defined, X2, negative 5X1 plus 13X2, negative 7X1 plus 16X2. That's how it is defined. When this first coordinate here is X1 and the second one is X2, like that. So X2, according to how it is defined, you start with X2. In this case, X2 is 1. So up I have a 1. Then the second one is negative 5X1. In this case, X1 is 5. So this will be negative 5 times a 1 plus 13 times the... No. X1 is a 3, sorry. In this case, X1 is a 3. Then X2 is a 1. So this is negative 15 plus 13. Negative 15 plus 13, that is negative 2. Then also this one, negative 7, X1. What is X1? X1 is 3 plus 16 times X2. X2 is 1. So this is negative 21. Negative 21 plus 16. That is negative 5. Like that. So I applied the same formula in determining TU2. TU2, what is our U2? Our U2, according to the question, is 5, 2. So I applied that formula of the transformation you start with. So this is my X1. This is my x2. So you start with x2 up, that is a 2. Then to obtain the second one, that is negative 5x1 plus 13x2. Negative 5 times x1, which is 5, plus 13 times 2. So this is negative 25 plus 26, and that is a 1. Then the last one is negative 7 x1 plus 16x2. So this will be negative 7 x1 is a 5 plus 16x2, which is a 1, which is a 2 here. So that is negative 35 plus 32, negative 3, like that. So now I have my TU1 and my TU2. But these are coordinate vectors here. I just have TU1, but haven't yet established the coordinate vector of TU1 with respect to B prime, and also the coordinate vector of TU2 with respect to B prime. That's what I want to obtain. Yeah. So I think this session is ending. Use the same login details.